Electricity, an invisible form of energy, influences our lives in various ways. Its importance can be felt only when the power supply in our houses and neighborhood breaks down. Electricity can be transmitted over long distances to our homes, factories, offices, and cinema halls with the help of wires from power generating plants. Think of what life would be without electric bulbs, fans, television, refrigerators, washing machines, and computers. Conductors and insulators. In earlier class you have studied about conductors and insulators. Conductors allow flow of electric current as the atoms of these materials have a large number of free electrons. Insulators, on the other hand, do not have free electrons, hence do not conduct electricity. Both insulators and conductors are important and have equal utility value because every conductor needs to be insulated in some form. Electric charge. When a body like glass or plastic is rubbed with wool, silk or fur, these bodies acquire a property of attracting small objects as bits of paper, hair, etc. The bodies are said to be charged or electrified. In non-conductors, this charge does not flow in a current, hence this charge is often referred to as static electricity. The friction of rubbing of two objects causes the movement of loose electrons from one object to another. The loser of electron becomes positively charged while the gainer of electron becomes negatively charged. Current electricity. A remarkable quality of electricity is its ability to move along preset courses of conductors called circuit. But how can electricity move from one object to another? What is the unbroken path of the circuit? From what material is the circuit made? By using simple batteries in the following set of activities, you will be able to understand how it is possible to tame this powerful force of electricity so that we can use it every day. Electron flow and conventional current. The flow of electrons due to potential difference between the battery terminals causes electrons to move in a particular direction. This flow of electrons causes current in a wire. The direction of current is taken as opposite to that of flow of electrons, that is, from positive to negative terminal of the battery. How does electricity move? From the electrical charge point of view, the number of protons in an atom is equal to the number of electrons, so that the atom as a whole is electrically neutral. It is possible for the electrons to become detached from their atoms in a body so that it is left with a net positive charge. On the other hand, if the body gains extra electrons, it acquires a net negative charge. Protons and neutrons constitute the nucleus of an atom. The electric current is generated when electrons are in excess in an electrified object and are free to move towards an object which is less charged, where there is deficit of electrons. This difference in charge between one object and another is called potential difference. The battery is able to maintain a certain difference in potential difference between one end of the circuit and the other. Battery. A combination of more than one electric cell is called a battery. The positive terminal of one cell is connected to the negative terminal of the next cell. In such devices, the cells are either placed one after the other in series or side by side in parallel. Batteries are used in torches, toys, cars, etc. Circuits and switches. When you want to put off a light or a fan, what do? The switch that you use for this purpose works by breaking the electric circuit. It is a small bridge which joins the circuit which has been temporarily broken and allows us to use electrical equipment whenever we need them. Some common electrical symbols. A standard method of drawing an electrical circuit is called circuit diagram. We use symbols for sketching electric circuit diagrams of various components like cells, wires, switches, bulbs, etc. The following table shows some common electrical symbols used for a given electrical circuit. Electrical component, symbol. Electric circuit. Thus, for the sake of simplicity, an electric circuit is represented by circuit diagram using these standard symbols. Otherwise, the actual electric diagrams would require drawing of the cells, bulbs, wire, etc., which would not only be time consuming but difficult to draw too. Using these symbols, let us now draw the circuit diagrams for a closed circuit and an open circuit as shown in the previous activity. The arrow in figure A indicates direction of conventional current, whereas the direction of electron flow will be in opposite direction. When the switch is on, the circuit is closed. The electric current flows from the positive terminal of the battery to the negative terminal instantly and bulb glows. When the switch is off, the circuit is open. No electric current flows along this broken or incomplete path through any part of the circuit. The bulb does not glow. Effects of electric current. Can you imagine what everyday life would be like without electricity? The advantage of electricity is the ease with which it can be converted into heat energy, light energy, magnetic energy, and chemical energy depending upon the way we use it in a particular device. We will discuss about the heating effect and magnetic effect of electricity in this section. 1. Heating effect of electric current. At home, we use electrical appliances like electric bulbs, fluorescent tubes, electric heaters, irons, electric toasters, and electric ovens. In using these appliances, the electrical energy is consumed. What is the common phenomenon occurring in all these appliances? All these appliances produce heat when electric current passes through them, which means the electrical energy is being transformed into heat energy. Common electrical appliances. Many electrical appliances like electric irons, electric cookers, toasters, hair dryers, electric ovens, immersion heaters, and hot plates that we use at our homes have a heating element. The principle of changing electrical energy into heat energy with the passage of electric current is applied in these appliances. Normally, all heating appliances consist primarily of two parts. 1. A resistance called filament, which is a coil length of nichrome wire. This wire has high resistivity and a high melting point. 2. The insulating base made of fire clay, mica, silica, or asbestos in which the filament is embedded. These materials are also able to withstand high temperature of the filament and are non-conductors of electricity. The electric bulb. The electric bulb consists of a coil filament made of tungsten in an evacuated and sealed glass bulb filled with a mixture of argon and nitrogen gas at a low pressure. Modern filaments are made of tungsten, which last longer and gives white light. When electric current is passed through the filament, it gets heated to such a high temperature that it starts glowing. The advantage of using tungsten filament is that it has a very high melting point and a very high resistance. Nichrome. Nichrome is an alloy containing 60% of nickel and 40% chromium. It resists oxidation even when red hot, and its temperature can rise up to 900 degrees Celsius. Compact fluorescent lamps. Compact fluorescent lamps, CFLs, have an average lifespan of 6 years, and each bulb provides a saving of 80% in consumption of energy. That would mean a saving of 34 kilos of CO2 per lamp per year. These days, LED bulbs are also made. They save electricity even more than CFLs, and they are free of mercury. Electric fuses. What would happen if electric current was not kept under control? Imagine a situation when the flow of electric current in the circuits operating in your houses exceeds beyond the normal level. It would cause the wires to get overheated, which would cause damage to electrical appliances and even lead to fire in the wiring. Such a situation may arise because of a faulty circuit. The common problems we may encounter are 1. Fluctuating voltage, 2. Use of higher load appliances, 3. Connection of many devices to a single circuit, 4. Short circuiting.
To protect the electrical installations in the houses or buildings, we use safety valves called fuses in the circuit. It is a metal wire connected to live wire.
The fuse wire is made up of a suitable alloy which has low melting point, tin, or an alloy of copper and tin fitted in a cartridge made of porcelain or glass. When a current which is stronger than the circuit can support tries to flow through the circuit, the fuse wire melts due to overheating and breaks the circuit. The fuse thus opens the circuit and interrupts the flow of current. Thus, in an electrical wiring, the fuse is the weakest link. Miniature circuit beaker. These days, miniature circuit beakers, MCBs, are used to replace the fuse as they are automatically operated electrical switch designed to protect electrical circuit from damage due to overload or short circuit. These can be reset either automatically or manually to resume operations.
Circuit breakers are made in varying sizes, from smaller devices that protect an individual household appliances up to large switch gear designed to protect high voltage circuits feeding an entire city.
2. Magnetic effect of electric current. You have studied about magnets and their properties in class 6th. You also know that a magnet, when suspended freely, will always align itself to the north-south direction. In 1820,
Hans Christian Ørsted,
professor of physics at the University of
Copenhagen,
made the discovery that a wire conveying current was able to deflect a pivoted magnetic needle. Thus, he was the pioneer in establishing the relationship between electricity and magnetism. On further investigations,
Ørsted
found that the direction of the deflection depended on the direction of the current and also on whether the wire was above or below the needle. We know that a magnetic needle can be deflected only by another magnetic field. Magnetism produced by current is called electromagnetism. Electromagnet. If we keep a piece of soft iron inside the coil and pass electric current through the coil, the piece of iron gets magnetized temporarily. Such magnet is called an electromagnet.
Electromagnets can be made stronger by winding large number of turns of a wire of a conducting material like copper. The wire should be insulated and wound round a piece of soft iron.
Soft iron behaves as a temporary strong magnet when current is passed through the coil. The substance around which the coil is wound is called a core. The coil, also called solenoid with a core, is called an electromagnet. However, when the current is switched off, the iron loosens its magnetism. Solenoid switch. It is a device made of a long wire that has been wound many times into a tightly packed coil. It has the shape of long cylinder, used as switch for cutting off electricity to devices. Uses of electromagnets. Electromagnets are widely used in household appliances, in automobiles and industries. 1. Powerful electromagnets attached to large cranes carry heavy loads of iron and other magnetic substances used commonly in shipyards. 2. Electromagnetic separators are used for separating magnetic substances such as iron, steel, nickel, and cobalt from non-magnetic substances such as tin, brass, and copper in various industries. 3. They are used to remove foreign bodies such as iron nails from a human body. 4. Electromagnets are used in electric bells, telephones, transformers, electric telegraph, speakers, etc. Electric bell. An electric bell works on the principle of electromagnetism. It consists of a gong, a horseshoe electromagnet, an easy to magnetize soft iron bar with a hammer at one end, and a contact screw arranged in a circuit as shown in the figure. When the switch is closed, current flows through the winding of the electromagnet, causing the soft iron bar to get attracted to it. When the soft iron bar is pulled towards the electromagnet, the hammer attached to it hits the gong of the bell and produces a sound, thus causing it to ring. As the soft iron bar moves away from the contact screw, the circuit is broken. The electromagnet loses its magnetism and the soft iron is pulled back to the contact point by the spring action. This completes the circuit and the cycle is repeated. Thus the hammer will vibrate against the gong and produces a continuous ringing as long as the switch is closed. Hazards of electricity. Electricity is one of the most popularly used forms of energy in the modern society. However, electricity can be dangerous if proper precautions are not taken. The following are the hazards of electricity which should be taken care of. 1. Touching a live electric wire gives a dangerous shock. When current passes through our body, it damages the cells and tissues. 2. As water can conduct electricity, it is extremely dangerous to touch electrical appliances with wet hands. 3. Fuse wires of specified thickness should be used in fuse boxes. 4. One must have maintenance check in house wiring and appliances for broken insulation, loose connections, worn out switches, and moisture accumulation. 5. House wiring must have proper earthing and appliances must use a 3-pin plug. Power cables and safety. Electricity is dangerous unless safety precautions are taken. For example, a small electric current passing across the heart is enough to kill. For safety, power cables have 3 strands: live, neutral, and earth. 1. The electric current supplies energy to the house through the live wire and it returns through the neutral wire. 2. The live terminal alternates between positive and negative voltage with the neutral terminal staying close to 0. 3. In normal use, the earth wire does not carry any current. 4. The strands are insulated to make sure that no current passes between live and neutral and earth wires. Conserve electricity. Each one of us has a responsibility to prevent misuse of electricity by developing proper habits. 1. Put off all electrical appliances when not in use. 2. Encourage use of CFL and LED lightnings.